Hola, my children. Okay, today during 7th period, a student asked me, can you show me where this comes from? And I said no, because I needed you to be focused on learning the rule. This is not mandatory for you guys to learn. You're probably going to get confused when I show you. I decided on the way home that maybe I should show you, but I definitely didn't want to do it in class because it's a lengthy proof. You're probably not going to know why I'm doing some of the things that I'm doing, although I'll try to explain it the best I can. Remember, you're kind of limited in your math knowledge, especially when it comes to proofs, so some things are probably not going to make sense, which is why it's just better not to deal with it. If you guys were more exposed to proofs earlier on, like in pre-calc and algebra 2, then naturally you would see some things. But many of you are a little bit rusty. Some of you are a lot rusty in your algebra. So anyway, this is not for the faint of heart. It's not that difficult, but it does require that you rely on some really strong knowledge of algebraic skills and identities and things like that. So I'm going to do it, so you can see where it comes from. And anyway, you can make a cup of cocoa and curl up in your chair and see if you can follow along. Okay, so what we're going to try and do is find the derivative of a quotient. How do we get the quotient rule? How is the formula derived? Okay, and this is going to be proof of where it comes from. So what you need to do, or how you need to think of as this whole thing as your f of x. So it's no different than me saying what's the derivative with respect to x of a function f of x. Okay, well, we know that we can find the derivative by taking the limit as h approaches 0 of f of x plus h minus f of x all over h, and we'll get a new function, right? Well, we're going to treat this thing here in brackets, this quotient, as the whole function, as f of x. So in doing that, we've got the limit as h approaches 0 of f of x plus h over g of x plus h minus f of x, which is f of x over g of x, all over h, right? And I'm going to clean up that numerator, and I'm going to do it the quick and easy way. I'm going to cross multiply to get the numerator. So this, right, if I multiply those two and I cross multiply those two, that's going to give me the numerator components, and then I divide that result by the product of the denominators, which would be the common denominator. So this is going to be the limit as h approaches 0 of f of x plus h times g of x minus f of x times g of x plus h all over g of x times g of x plus h all over h. Okay, so all I've done from here to here is, I know it doesn't look like it, but I've simplified the denominator by finding, the numerator by finding a common denominator. And what that means is we've got this ugly complex fraction, however, the denominator of the numerator is just going to drop down. So we've got the limit as h approaches 0 of f of x plus h times g of x minus f of x times g of x plus h all over g of x times g of x plus h times h. And then what I'm going to do is I'm going to use some rules of limits, right? So what you have to realize is that this is the same, so over to the side here, this is the same, forget about the limit for a second, I'm just focusing on the fraction, as 1 over g of x times g of x plus h times h times f of x plus h g of x minus f of x times g of x plus h over 1 if I want to. But instead of putting this over 1, I'm going to move this h over here, like so. And since that's a product, I can use rules of limits. So I'm going to say the limit as h approaches 0 of 1 over g of x times g of x plus h times the limit as h approaches 0 of f of x plus h g of x minus f of x times g of x plus h all over h. Okay? And over here on this left-hand factor, right, so this is a factor and that's a factor, but over here, I'm going to take the limit because it's easy. If I plug the 0 in for h, I get 1 over g of x times g of x, which is 1 over g of x squared, right? So that part is finished. Now I got to work on this. I'm going to have to use some creative mathematics, although it's very sound. Hang on, I'm taking a sip. It's very sound. But again, you have to remember some rules of algebras, and I'll try to explain it the best I can, because I'm going to use an identity. And the identity I'm going to use is this. I'm going to write the limit as h approaches 0 of f of x plus h, g of x, minus f of x, g of x, plus f of x, g of x. So I'm inserting this sort of in the middle between this and this, minus f of x, g of x plus h, all over h. Okay, so here's my f of x plus h minus f of x, and this is the part I'm inserting. It equals to 0, so it changes the way it looks, but it doesn't change the value, right? So I'm using that identity, that negative f of x g of x plus f of x g of x, which is 0, right? If I add 0 to this, I'm not changing it, right? So I'm adding 0 to this because I need to change it in order to fulfill the proof. So I hope that that makes sense, but I don't know if it will. And at this point here, I'm going to start playing around with the numerator. So we've got the limit as h approaches 0. And what I'm going to do is I'm going to pull out this g of x. So I've got 4 terms in the numerator. And if you remember when you used to factor by grouping, right? You had 4 terms and then you'd factor them by grouping. That's what I'm going to do. I'm going to factor that numerator by grouping. And so what I'm going to do is I'm going to pull out a g of x as though it's a constant, and the reason, a constant multiple, and the reason why I can do that is there's no h in there. Alright? So I'm going to have g of x times f of x plus h minus f of x. Look familiar? So I'm just working on this piece right here. I'm pulling out g of x. It doesn't contain an h, so I can treat it as a constant multiple. I factored out the g of x from those 2 terms, and I'm left with f of x plus h minus f of x, which is from the difference quotient, right? Hang on, Ella, hang on. And then I'm just going to subtract from that I'm not going to subtract, but I'm going to pull out a negative f of x over here. So on this one now, right, f of x is common, and I'm going to be left with g of x minus g of x plus h. And again, that's all over that h. And since they share the same denominator, well, now I can put this over the denominator minus that over the denominator. So let's do it. And I'll probably rearrange the terms of the second, hey, where's my, okay, sorry. Okay, Ella, hang on. I'm going to rearrange the terms of my numerator. So what I've got here is the limit as h approaches 0 of g of x times f of x plus h minus f of x all over h minus f of x times, so I'm going to rearrange these two, times g of x actually, yeah, that's okay. G of x minus g of x plus h all over h. I hope that you're following that. So at this point here, I can do something kind of nifty with this. What I can say is that I know that this is the limit of the difference quotient, right? So I'm going to pull this g of x out because it's a constant multiple times the limit as h approaches 0 of f of x plus h minus f of x over h. And what is this thing right here? This thing right here we defined as f prime of x, right? So what I've got is g of x times f prime of x. G of x times, that's the definition of the derivative. We defined that earlier, right? I'm sorry, my dog's going a little bit ballistic. And by the way, I decided I should rearrange this. I should write this as negative f of x times positive g of x plus h minus g of x. Because that negative will make that negative, and it should be, and the negative will make a negative f of x times g of x will make that a negative. Okay, so I'm just rearranging the way that I write it. So by the way, right, I've got this minus f of x, right, times g of x plus h minus g of x all over h. And I didn't put my limit notation there, so let me insert it right here. If I pull this out as a constant multiple on this side and take the limit as h approaches 0, I've got a little bit of a problem there, right? Because I've still got that h there, but I'm not really taking the limit. I know that this again is the derivative. This right here is the derivative. So it'd be minus f of x times g prime of x. Woo, look at that. Imagine that. And don't forget, way up here, this was times, right? I said we're finished here, but we're not done. I mean, we have to bring this down. This is times every step. So what I'm left with is 1 over g of x squared times g of x times f prime of x minus f of x g prime of x over 1 if you want to think, oops, I'm sorry, if you want to think of it that way. And now if I multiply them together, I get g of x, f prime of x, minus f of x, g prime of x, all over g of x, squared. And that is equal to the derivative of f of x over g of x. So I'm going to use prime notation here, right? And by the way, it's low times the derivative of high minus high times the derivative of low over low squared. If you want to use that little, if you want to use that little, I don't know what you call that little thing, that little song or whatever you call it. Okay? And so that's how the quotient rule is derived. And by the way, you can do the same thing with the product rule. So if you're bored, take out your limit definition, because yes, it all boils back to the limit of the difference quotient. And it takes some work, and it takes some strong algebra. And again, you may have gotten a little bit confused over here where I added 0. Don't worry about it. If you don't get it, don't worry about it. Just know the rule. Low d high minus high d low over low squared, or the actual mathematical rule, which you need to know. And that's all you need is the rule. You need to know the rule, and you need to know how to apply it. You need to know what to substitute into what to get the derivative correctly. Alright, so I hope you had fun with that. I did. Now I'm going to go play Frisbee with my dog. Have a great night.